In this movie, I want to explain how the AI enemy C# class works here. So I've opened up that script file inside Unity. You can find this file in the completed course companion files associated with this course in the line of sight folder inside the Unity project. And so I have the AI enemy.c# file here, and much of this has remained the same from before. So again, we have our enumeration defining the different states, and we also have the current state C# property that allows us to change between states by initiating specific coroutines. So here is one example, here is another, and here is another one. If I scroll down further here, we can see some additional variables that have been added, most of which are private variables. So we have a reference to the transform component, that is for the NPC object. We have the navmesh agent. We also have a reference to the line of sight component. Now, this is the component we coded previously to determine whether the NPC has a clear line of sight to the player. We need access to this so we can determine whether the NPC can see the player, because this is important for determining when a state should change. For example, when the chase state should change to the attack state, or when the patrol state should change to the chase state. Down here further, we also have access to the player transform component, that is to the position of the player in the level. And we also have access, as we've seen before, to the patrol destination, the object that the NPC should follow when they are patrolling. And then finally, we have the damage amount. This is the amount of damage that the enemy should deal per second when in attack mode and when attacking the player. And as before in the awake function, we can see that we're getting a reference to all of these different components. And this really is nothing special. We've seen all of this kind of behavior before. In the start function, however, notice that we are assigning the current state variable the patrol state. That means that when we run this line of code, this will execute the C# property that we can see further up here to initiate the start coroutine, which is the patrol coroutine. So I'm going to scroll down further inside this source file here, and we come across the very first state, which is the AI patrol state. Now I'm going to have a look quite deeply at how this state works, because this is in some sense self-governing. That is, we have our loop that loops constantly while the state is active and performs important functionality that determines when one state should change to the next. In this case, we are looking to see when we should change from the patrol state to the chase state. It is not possible to change from patrol directly to attack. To get to the attack state, the patrol state must first change to chase, and then from chase to attack. So right now, this function here, AI patrol, is determining whether we should remain in patrol or whether we should change. So the first thing that the AI patrol state does is to set the sensitivity of the line of sight algorithm, and you can see this here at line 82. The sensitivity of that algorithm is being set to strict. That simply means that the NPC is classified as seeing the player whenever the player enters the field of view, and there is a direct line of sight between the NPC and the player with no intervening physical objects. This kind of strictness makes sense because while the AI is patrolling, they have no reason to think that the player might be lurking about. They have no reason to think that the player is hiding or running away. They are simply patrolling. The next thing we want to do is to communicate with the navmesh agent by using the resume function. It's possible that on previous occasions, the AI may have been assigned a path already and have reached the destination and have been told to stop. When the agent is told to stop, we need to resume it. So just in case the agent has been told to stop, I am resuming the agent. In the next line, I'm using the setDestination function to move the AI to the patrol destination position. Remember that the patrol destination is going to be an empty game object moving around the level on a waypoint system by using an animation. Now, once the destination has been set, the navmesh agent may spend a little while calculating the path necessary. In the simple level that we have created, it would take the agent no time at all to calculate, but in more complex levels, path calculations may take longer. So I'm waiting until the path is fully calculated before proceeding on with the next functionality. The next functionality is simply one question. Can the NPC see the player? If the answer to that question is no, then simply we loop around and the NPC continues to patrol. But if the answer to that question is yes, then the agent temporarily is stopped and we are switching to a new state, that is the chase state, to chase the player, and this coroutine is terminated. That effectively is how AI Patrol works. Next, I want to have a look at the chase state.